So it seems that from the 3.4 day one, the concavity go formative, it seems like most of your issues are coming from 7 and 8. So I have that on the screen and we're going to work through that and hopefully you can figure out maybe where your mistakes are. So in order to find our intervals of concavity, we have to find the second derivative. So we'll find the first derivative. We use our quotient rule, so low d high minus high d low all over low low. So let me simplify that because we're going to have to find a second derivative. Okay, so let's see, we'll have 4x squared plus 2x minus 2x squared plus 2 over 2x plus 1 squared. That's going to give us 2x squared plus 2x plus 2 all over 2x plus 1 squared. Don't really think there's a whole lot more we could do. I mean, we could factor out a 2 there, but it's not going to form a giant one with anything. So that's our first derivative. So then we'll go to our second derivative. And we'll have to use the quotient rule again. All right, so low, which is 2x plus 1 squared, d high, which is going to be 4x plus 2, minus, and then high, which is 2x squared plus 2x plus 2, d low. So we're going to have to use the product, or I'm sorry, the chain rule for that one. So that's going to end up being 2 times 2x plus 1 times 2. All right, and then all over low low. So 2x plus 1 squared. So there's a lot to unpack here. Here's what I do notice, though. Actually, that's 2x plus 1 squared. What I do notice is that there is a factor of 2x plus 1 in every term. So essentially, that's going to be, if I factor that out and then cancel that out, that would be a giant one. So let me write what's left after I get rid of that factor of 2x plus 1. So we'll still have a factor of 2x plus 1, and we're going to multiply that by 4x plus 2, minus. So this will be gone. One of these is gone, and then one of these is gone. So that'll be, we're going to end up with one of these being gone, and that'll be to the third power. I'm trying to find the best way to write that, and it's not working, but this will all end up being to the third power. Okay, so inside the parentheses in the numerator here, I'm going to have, this will be 4, and then I'm going to multiply that 4 times everything in here. Okay, so we'll have 8x squared plus 8x plus 8. And then all over 2x plus 1 cubed. Okay, so simplifying that a little bit further, f double prime of x is, if I multiply out the binomials in the numerator, I'm going to have 8x squared, and then we'll have 4x plus 4x is 8x plus 2. And then we'll have minus 8x squared minus 8x minus 8 all over 2x plus 1 cubed. And let's see, that's going to just be negative 6 over 2x plus 1 cubed. All right, so we've got our second derivative. Now, what we need to do is we need to find those places where the second derivative is equal to 0. Okay, that's part of what that test for concavity is. So, we'll set our second derivative equal to 0. So we're going to have 0 equals our second derivative. Well, there are no places that are going to make that 0, because if I multiply both sides by 2x plus 1 cubed, I end up getting 0 equals -6. So there's no places where our second derivative would be equal to 0. So then we have to look at, when is our second derivative undefined, right? And that's when our denominator is equal to 0. So if I take 2x plus 1 cubed and set that equal to 0, I need to figure out at what places will that be 0. So I would have 2x, take the cube root of both sides, 2x plus 1 equals 0, and I'll get x equals -1/2. So that gives me, a way to set up my intervals. So my table is my next step. So I've got my number that I'm going to use to help me set up my table. So my table is going to look like this. I'm going to have my interval, and I'll have everything less than a half and everything more than a half. So we'll have everything from -infinity to -1/2, and then we'll have everything from -1/2 to +infinity. So those are my intervals. I have to decide, are they concave up or concave down? So I do that by figuring out my test value in that interval. So for me, I'm thinking between -infinity and -1/2, maybe -1. And then between -1/2 and infinity, maybe I pick 0. And then I look at what happens when I plug in f double prime of x. Is it positive or negative? That's what we're looking for here. Okay, so is it positive or negative? So let's do that. Let's plug in f double prime of -1. Let me make sure we can actually see that on the screen. Okay, so we have -6 over 2 times -1 plus 1 cubed. Well, let's see. You could use your calculator for this, but I think we can probably do it pretty easily. -6 over, so 2 times -1 is -2. Plus 1 is -1, cubed is -1. So we end up with a positive number. All right, now our conclusion is, would this be concave up or concave down? So if our value at our test, if our derivative at our test value is a positive number, then we know it's concave up. Okay, so that's the first part of this. Second part of this would be plugging in 0 into our second derivative. So I'll have -6 over 2 times 0 plus 1 cubed. And let's see. Let me fix that a little bit here. So at second derivative at 0 is going to be -6 over, that'll be 0 plus 1 cubed is just 1. So that's -6. So that's a negative number. So what I now know is that because our value of our second derivative at that particular x value, it's negative, so our function is concave down. So your answers are going to be, when you put them into your Go formative, when it says for number 7, on what intervals is the function concave upward, you would say from -infinity to -1/2. And then 8 asks, on what intervals is the function concave downward, you would say from -1/2 to +infinity. Okay, I hope that helps a little bit. I know it's a little long. I just wanted to make sure we took our time through that. You could see that these are reflected in the graph. So if I go back up here and look at the graph, right? So -1/2, let's look at where that is. -1/2 would be like right here. Okay, and that's where we switch from being concave up to concave down. So everything from here and to the left is concave up, but then everything from here to the right is concave down. All right, and that just so happens that that's where our asymptote is, right? So if you're looking at this guy, this part of my graph is concave up, and this part of my graph is concave down, it sort of makes sense. Remember the idea of a bowl or an umbrella, right? This kind of looks like if you put water in it, it would hold water. This looks like if you poured water on it, the water would run off the sides. Okay, we'll go over any other questions you have from this assignment tomorrow. Hopefully that helps, and I will see you then. Have a great night.